to mute because we got some interference when you were talking. But
okay, here it goes.
Okay, so all right, so let me get started. Here's the obligatory marketing slide, which our marketing department insists that we put in each presentation, so I'll skip past it. Okay, so let me talk about what AIM is. And it's just part of our grand scheme for world domination, but it's another small step in that direction. And what it is content-based access to the data. And typically, content-based data is cross-references in statistics, but certainly, in the future we can add more things to it. The whole idea is that it's a framework for doing metadata, and over time we'll do more and more. But right now it's cross-references in statistics. And the simple answer is, why do we do it? And the answer is performance. And all applications at some point have metadata. So essentially, all applications need better data, and certainly at least cross-references. And we've talked about the earlier talk about FileMan cross-references. Well, Octo does its own, and AIM is going to be doing that as well. So all applications need better data, but the thing is, they keep reinventing the wheel. And what this means is that you're duplicating code, you're duplicating resources, you're introducing different bugs, and we found ourselves doing this for Octo, and that's when we said it really doesn't make sense sort of doing it one application at a time. We'll just do it once and for all, and then it will meet the needs of all applications. And you'll see that we're starting with one type of schema, one type of metadata, but then the framework is there to expand it, and that's what we're doing. I'll be talking about that. So let's take a sample use case. So let's say we have histories are us, and they get a support call. And since it's Halloween, we're not going to worry about whether the former presidents are alive or no longer with us in person. So they get a support call that says, "Hi, I'm George. I'm a former US president. I need to correct my record." So now what the application needs to do is find the record. And if this is a common sort of thing, the application would have its own metadata and its own cross-referencing to find the record for someone called George. So this is what the globals for former US presidents might look like. And I just somewhat, for demo purposes, there's only 3 pieces in the node, and there are 2 subscripts: the date that a president was inaugurated, and the date that the president stopped being the president because there was a successor or they passed away or whatever. So this is just the first introduction. Using AIM, how would you find presidents named George? So what you do is you first call this function called xrefdata, and you pass it a bunch of parameters that says basically cross-reference the global called US presidents. It has 2 subscripts. The piece separator is a vertical bar. I want the first piece separate to be cross-referenced. And that last parameter 2 says, give me statistics as well. So then if you look at what X returns the name of a global variable. And that global variable is just a hash. Other than the prefix, it doesn't mean anything. I'll be talking about how we generate that global variable. But now you can write a simple loop of M code, which will execute fast, which now gets you all of the presidents called George, and the application records for those presidents. And by the way, anyone who's following the mumps code will know that this query is actually a bogus query, because it's just returning the first president that for that year. And if that first president who's, that year happened to be someone other than George and that person happened to die in office, then you're going to get an answer that's not George. So you actually need to do a little bit more complicated mumps query, but this is fine for right now. Also, I'll apologize for using the abbreviated forms of commands because I want everything to fit on one line without having to shrink the font. So now this is the results of the query. We can then look at what the cross-reference globals themselves look like. So here's that cross-reference global. The first subscript 1 says this is a cross-reference for the first piece of the global variable. And then it gives you the values. The second subscript is that value of that piece. And then it gives you the subscripts of the application global variable that contain the data called George. And here, as you can see, there are 3 application globals that have George as the first piece. So one of the important things about triggers is, they help you maintain consistency every time. So for those who have not used YottaDB or the upstream GTN, what that is when there is a global variable update, a set, a kill, or a zkill, it will actually run. You can set up a trigger that runs when that update is made, and when that update is made, you can it will run this M code. So that way you can maintain things like cross references, which are always guaranteed to be consistent with the application code. And so the first line I have out here is actually some metadata about the metadata. So in that long global variable name, all the nodes that have single subscripts, which are numbers, are essentially metadata about the data itself. And in this case, the 3, that piece is the pieces of the global variable that are being referenced. And here we can see, for example, that the hash mark is just something that makes sure that what's out there doesn't get converted to a number. But it basically says, in this particular example here, we're doing cross-referencing for the first and the third pieces. And to show how the triggers maintain the consistency, let's just say that in the year 4241 and through 4245, the president is Zafar Beeblebrox. And so now you can look at the data, and sure enough, just by setting that particular global node, the cross-reference is created. And then if you delete that global node, that cross-reference goes away. So the cross-reference and the application global are always consistent, and that consistency is maintained with triggers. And the triggers execute inside TP transactions. So, and one of the things that this code base has is really strong transaction processing. Okay, so let's look at what the parameters to that function and look like. So the first parameter of xref data is it's just the global application global variable that you're cross-referencing. The second is the subscript specification. Now, in the example that I gave, it is just a simple number 2, but I'll be talking about how you can make it more sophisticated than that. There is a piece separator. If you don't specify a piece separator, it means you want the entire global node cross-referenced. And then if there's a piece separator, there's a piece selection where you can specify which pieces you want cross-referenced. And one of the things you can do, I'll talk about this also in a minute, is let's say the first time you run it, you just cross-reference the first piece. And then later on, you come back and it says, well, which George are you? And he says, well, I'm George Bush. Well, then you can run the cross-reference and say, okay, now which George Bush are you? So, that kind of thing. So you can actually add to the cross-referencing, to the pieces that are cross-referenced in real time. And then there's a parameter that says, just give me the metadata variable name. Don't actually set the triggers or compute the metadata. And you can use this, I'll talk about that in a moment, to make your application code more efficient. Then the next one is Z piece, because YottaDB handles within the database, everything is just bytes, but the application process can use piece separators, which are either bytes or which are UTF-8 characters. And so that's a way to specify that in UTF-8 mode, you actually want to use the byte separator rather than the character separator. Then omit fix, and this is one that says in the cross-reference, omit any subscripts of the application global which are constants. So in the case of VistA, for example, because the subscripts are alternating variables and constants, you don't particularly, if the application knows what you're cross-referencing, you don't need the constant subscript in the cross-reference. And then what's in production right now, we have statistics, and the default is no statistics, cross-references only. And then you can also get by setting it to 1, you get a count of each value. And then 2 says count of each value as well as the total number of values. And what we're now implementing is, so the default right now for type, which is not implemented yet, is just sorry, let me correct myself. The type parameter has not been added. The rest of AIM is actually production grade code. So right now the global schema that's cross-referenced is flat, but FileMan, for example, has got a special casing of nodes where the subscript is a constant but missing an action. So we'll be doing that next. And then as other applications need their schemas to be cross-referenced, we'll deal with those as well. So let's talk about that funny looking global variable name. It consists of a prefix, and anything that starts with %ydb is ours, and %ydb aim is application independent metadata, and D is just the data. So that's our prefix. And the suffix is actually an alphanumeric 128-bit murmur #3. And so this is an extremely fast hash, which has excellent statistical properties. And so we're pretty much guaranteed, because it's a 128-bit hash, that you're not going to have hash collisions. Except, of course, if you happen to, for anyone who happens to read the Hitchhiker's Guide to the Galaxy, there is this thing called the infinite improbability drive, but we don't deal with that here in our world. And there's a function called zy suffix, which takes a string and gives you a 22-character alphanumeric 128-bit murmur #3. So we take the parameters, and then from the function parameters, we compute the suffix. Oh, and by the way, this is the reason that this won't run directly on GTM, because they haven't implemented the $zy suffix. If they were to, then everything else would run on GTM as well. Okay, so now I'm going to go through some of the parameters of the xref data function. So the subscript specification can be of 2 kinds. One is just the number of subscripts, and that's what we did in the example where we just passed the number 2. But you can also pass in a local variable that specifies ranges or combinations of ranges. So for example, if you were to set the local variable s, and you basically set the top level to 2, which says give me 2 subscripts, and then S1 is basically saying give me all subscripts for all values for the first subscript, starting from the first value through 1800, as well as anything that is 2001. So in the first case, it's a range, and then there's a semicolon, and the second case is a specific value. And then you pass that parameter by reference when you call ydb aim, and you can see the result is that you get George Washington and George W. Bush, but you don't get George H.W. Bush. And the piece selection is flexible as well. So in the first case, we said we're only going to cross-reference the first and third pieces. That's what that 1:3 is. And then later on, let's say if you get if you go back to the example that we talked about, where you get which George Bush are you, then you can cross-reference the second piece, and then you can do that cross-reference on the second piece, and you can add that to the original cross-reference. So adding a piece doesn't change the variable name, it just adds one more cross-reference or one more piece of statistics to the metadata. Okay, indirection. This is both the power of M code as well as sometimes the bane of M code for performance reasons. Now, there are ways of writing indirection to minimize the overhead, but the overhead is never zero. And in fact, if you examine the YDB AIM source code, you'll see how indirection is used to minimize the overhead. But one of the things that you can do is when you're writing application code, you don't actually need the metadata. You just call xref data with that name only subscript, which gives you the name of the metadata. And now you can write straight application code, which just writes to that. It writes the application, and then when the I'm stumbling over my words, my apologies. You can write application code that directly accesses the cross-reference, and all you have to do is, before you run it the first time, run that if statement, which actually goes out and computes the metadata and sets the triggers. But you can write your application code without the need to use indirection. Okay, and then there are two different kinds of statistics. The first one is just how many are there of each value. So if you look at the statistics for the first piece, and this is stored, by the way, using subscripts which are negative numbers. So if you say the subscript that says 1 and then Abraham, that would be the subscripts of the actual global variable. So -1 Abraham is the count of Abrams, and so you can see that there's one Abram as a former president, 2 Andrews, and so on. And then the other is the total number of distinct values there are. So you can see that for the third piece, there are 39 different last names for the 45 presidents. For the second piece, which is the middle initial, there are only 14 distinct values because many of them didn't use the middle name, at least in this particular global variable, and so on. And you can actually use this to optimize queries. So if you're saying, give me a query where the first name is Abram and the last name is Lincoln, well, that may not be a great example, but let's say you had that query. Now the question is, do you look first for Abrams and then look for Lincolns of the ones that contain the first name of Abram? Or do you look for the ones that have Lincoln as the last name and then look for the ones that have Abram as the first name? And you can use the statistics to minimize the number of global accesses by looking for the one that has the fewer number of instances first. And where the second statistics come into play, or let's say you have another global variable, which is all the capitals of the states, and you want to find out which capitals are named after presidents. Well, is it more efficient to look at last names of presidents and then see which ones have matching capitals? Or is it more efficient to look at all the names of capitals first and see which ones have matching presidents? So that's where the second type of statistics are useful. So from an operational consideration point of view, as you saw earlier, because you can just generate the cross-reference on demand with a single line of M code, by default, at least with YottaDB, we don't think that journaling and replication are necessary for AIM globals. So you just generate them as needed. If the system is running fine, shuts down normally, comes up fine, you have your metadata. If the system crashes or you come up, you just delete that region with the AIM globals, and they just get generated as and when they're needed. And this also means that if you're now making a copy of a system to run somewhere else, you don't need the AIM region. You just ship the rest of your globals without the AIM region, and now you have, a much smaller copy of the database that you're shipping. So by default, what the YDB env set does is it puts the AIM globals in a separate region. They get deleted on recovering from a crash. And also to avoid things like tuning and to maximize performance, they just use the access method, which directly maps the cross-reference into the address space of the process. And so this actually gives you great performance. Crash recovery is, you don't have to worry about crash recovery. It's just one of these things where it just works. So in terms of, where we are and where we're going. So everything I showed you today is production grade. You can download it, you can use it. What we're now working on is metadata for FileMan files. And once that's done, we'll switch Octo to we'll switch Octo to using AIM. Right now, Octo uses its own cross-referencing and metadata. We're working on a C API. We said YottaDB is language agnostic, and that means that the database can be accessed from any language. But that doesn't mean, obviously at some point code has to be implemented in some language. Now, we consider M, of course, all of you here are using M, but in general, in the broader world, people are not necessarily using M. So we consider M to be sort of our secret sauce, if you will, which allows us to write code fast and run fast code. And so what Octo does for that reason is it generates AIM code that the YottaDB engine then runs. But at the same time, to make AIM more generally useful, it needs to have a C API. So we're working on a C API. And once we have the C API, we'll follow through with extending the wrappers so that they have functions to use AIM. Right now, so we have a plugins manual. AIM is packaged as a YottaDB plugin. We need to have a section in the plugins manual for AIM. So right now the documentation is actually in the M code itself. And this is going to be kind of problematic for all of the M programmers in the world, because if you look at AIM, the number of lines of comments in the code is probably equal to the number of lines of M code itself. So it's kind of a shock. You can actually read the comments and understand what the intent of the code is, and then you can read the code to understand what the code does. So you don't have to read the code to understand what the intent of the programmer was. And then, as I said, we'll have APIs for other supported languages. And that's kind of the end of my slides. What questions do you have, and what would you like to know?
So the first thing is, it sounds like your coding styles are scandalous. But secondly, can you talk a little bit about testing and what kind of testing is being done with this?
So the answer to testing is yes. And there's a fairly extensive set of tests that Sam is working on, and he can probably answer in more detail. But he's using MUnit for the AIM tests.
So I'll take it from here. So David, we have MUnit that runs, and it actually verifies all the functionality. And we've actually found the bug in MUnit and fixed it. Good. For some tests,
Joe Livy started?
Sorry?
This is the MUnit that was started by Joe Livy?
It's the same one. Same one. And then the other thing we're doing is we have some tests that interact with the user, and these are basically run from a bash script, and they just spit out the answers out to the user that we expect, and we compare them against a file to see if that's what they're returning. I'm working on the C API right now, and that's being tested by CMOCA. So it's basically a way to just do unit tests on C code, and it just makes various assertions on what it expects and what doesn't expect. That's it.
I have a question. This is George Lilly. I'm a little you surprised me here with the notion that cross references as metadata can be recreated as needed. And in particular, if you do have a system recovery strategy that recovers data but not cross references, how do you? It's always been my impression that generating cross references takes a very long time if you have any substantial amount of data. So how do you decide whether to keep the cross references or not?
So George, let me answer that. That's that's an operational question. So if someone has an application database that is so large that on crash recovery, they want to recover the cross references, it becomes a fairly simple operational matter to go to the AIM region, set it to use journaling, and then if you're replicating, to also use replication. And that's really all there is to it. So it's just that, our sense is that in many cases, typically for crash recovery, if you need to rebuild cross references, that goes into the time to recover the system. And if you're running in a replicated environment, the replica will now pick up and run. But if you want to do replication and journaling and recovery for the AIM region, by all means, it's just a couple of commands that you run.
Okay, cool. Wow, it's challenging. It challenged my idea of whether or not you need to maintain cross references. That's very interesting. Thank you.
I mean, in some sense, it's not conceptually that different from, if the library card catalog burns down, but the library is fine, you can rebuild that card catalog. It's a pain, but then it becomes sort of an operational decision whether you have, 2 copies of the card catalog or whether you just regenerate the card catalog in the unlikely event the card catalog burns down.
Right. So I guess a follow-up question, and this is, you said the FileMan indices support.
Yeah, but the propensity for the card catalog to burn down happens right in the middle of meaningful use testing, by the way.
Right. Oh, I'm sorry. So is there
or any demo?
Well, actually, what I did was actually took code from a live terminal session. So what you saw in the screens that I had was actually real code that was copied and pasted. So I'm not sure what more I could demo. I mean, I could show you the same stuff, but it's running. It's running here on my laptop, and it can run on your system.
No, I'm just joking that it seems like whenever you want to do a demo, something goes wrong. Not you personally, but demos in general.
That's why I thought it would be safer to just do the demo on my own time and then copy and paste from the terminal session into the slides. I've learned, that doing demos is kind of like playing pool. You never call your shots with anything more sophisticated than watch this.
right?
Okay, so George, you were asking a question and you got interrupted. Sorry.
Yeah. There's in VistA there is a lot of very exotic cross references, and I guess the mumps. I guess the whole class of mumps cross references and mumps triggers and things, which are treated that they're cross references, but they're not. You can't predict how they're going to be formed. And so you provide a set and a kill for each one. You have a mumps code that's kept inside the cross-reference globe.
I'll take that.
The
Please,
traditional answer about that is that mumps cross-references have to be, in theory, creatable just using the main data. But in practice, your code doesn't have to actually succeed at doing all that it is. So especially in some of the pharmacy cross-references, I agree. There's some really crazy stuff out there.
It's some exotic, I call them exotic cross-references. But anyway, go ahead, Sam.
So we just to be clear, we what AIM is essentially close to the fileman classic cross-references. A combination of classic and new style, but basically there's no M style cross-references. They are always rerunnable and recreatable. So we do not send HL7 messages when something gets set, for example. That doesn't happen. So it's basically looking at data and just indexing it. That's all it is. There's nothing more to it. That's all it is.
Okay.
So that's why it's always recreatable.
All right, great. Thank you.
No problem.